All right, now we're on to chapter 3. So same thing as the other ones. We're just kind of going to go back and forth between this sheet and the work. So first question, a system of linear equations may not have exactly one solution. Well, that's not true. That can definitely happen. No solution. No, that can definitely happen. Infinitely many. That can happen. Exactly two. It can't ever have exactly two. The only options are one, none, or infinitely many. So the option that does not work would be letter D, exactly two solutions. That's not a possibility. Picture the way lines work. There's no way they could cross exactly twice. Second one, for number 2 and number 3, we've got these 4 options right here. Consistent and independent, consistent and dependent, inconsistent, and then inconsistent and dependent. So first of all, independent versus dependent. Independent means that they've got one solution. Dependent means that they've got infinitely many solutions. And then consistent means there is a solution. Inconsistent means there isn't a solution. So first of all, J is not possible. It's not possible to have no solution but have exactly one solution. So J isn't an option for us at all. But let's kind of work through number 2 and 3, and we'll talk about how we can figure out what the answer is. So 4x plus 2y equals negative 6. The best thing I could advise you to do is to actually go through and try to solve this. And the way they're set up, it's really good for elimination. So I would take this and I would multiply everything by 2. And when you multiply everything by 2, you're going to get these things to cancel out. So rewrite this as 4x minus 2y equals 16. And then we can line these up. So these will cancel. Kind of ignore that middle line. We'll have 8x equals 10, and then divide both sides. So like you get yourself to this point, and you're like, okay, so there's going to be a value for x, which means there's going to be a value for y, so I can plug that in and figure everything out. So you can pretty much just stop at that point. So you know it's consistent because there is an answer, and it's independent, which means that you've got exactly one answer. Okay, let's do the same thing for number 3. Okay, so we're just going to start and then see where it leads us, because it's fairly obvious pretty quickly whether you're going to have no solution or infinitely many solutions, because remember all the variables cancel out. So here, let's try to get the y's to cancel again by multiplying this by 2. So line this up down here. 6x plus 2y equals 6. And then again, the y's will cancel. We'll get 7x equals 10. So again, at this point in the problem, since all we're trying to do is choose the correct description, we can stop here because we know we're going to get one value for x. We'll plug it back in. It'll give us one value for y. So since we do come up with an answer, it's consistent, and it's going to be exactly one answer. So it's consistent and it's independent. Okay. Oh, and one quick note on this. Consistent and inconsistent, that kind of makes sense just logically, like, oh, it's consistent, there is an answer. Oh, it's inconsistent, there's no answer. Independent versus dependent, picture this as saying that the lines are independent from each other. If the lines are independent from each other, that means they're their own totally separate lines. They just happen to intersect at one point. If the lines are dependent, it's one right on top of the other. They're not independent lines, they're dependent lines. All right, number 4. Which system of equations is graphed? All right, so let's see if we can figure this out. So all of these is kind of an interesting thing to go off of. So one thing I would look at, especially since this is multiple choice, I would look at the 1, 3 and see if the 1, 3 is present on any of these. So if we try to plug 1, 3 into the first one, 3 and then minus 1/3 does not equal 0. So A is out automatically. Let's try to plug it in for C. 3 minus 3 times 1, that does give us 0. Okay, so this one looks good. 1 minus 3 equals 2. Nope, that one's out. Okay, so let's try this. 3 in for y. 3 minus 3 times 1 does equal 0. Okay, so that looks good. 1 minus 3 equals negative 2. Okay, so B looks really good so far. Let's compare D. 3 minus 1/3 equals 0. Nope. And then 1 minus 3 equals 2. Nope. Okay, so it's got to be B, just by plugging in this one point. So multiple choice was very, very helpful there, that they gave you all those options. Okay, number 5, looking at something similar. This time we're looking at inequalities. Okay, so first thing that I want us to look at is this line down here, because that's going to help us figure some stuff out. That's a horizontal line. Remember, horizontal lines are always just y equals lines, and the y value that they're using is a y value of -1. So let's look for the y. Okay, so the first one is all y and -1. Here's what we want to look at. The fact that it's a dotted line means that g is out, because it's not y is greater than or equal to -1. So greater, greater, greater. So those ones are all the same. So far all we've done is eliminate g, because it's not greater than or equal to. And then if we look at this line right here, this line is a solid line. So we know this other line does have an or equal to. So this one is fair game so far. This one's fair game so far. This one's out, because it's not just a less than. It's got to have the or equal to. So now we're between f and h. The only difference between f and h is that this one's a greater than or equal to, and this one's a less than or equal to. So just off a hunch, since we're shaded below, I'm going to head in this direction and think maybe it's less than or equal to. We're going to double check by plugging in the 0, 0. So is 0 less than or equal to 0 plus 1? And yes, it is. So h is what we're going for there. With 4 and 5, the multiple choice was necessary, because obviously you couldn't have figured out which one was graphed without the multiple choice. We won't really see any of those types of questions, but it's good to practice. Okay, use the system of inequalities, this, and then find the coordinates of the vertices of the feasible region. Okay, so I need graph paper. Okay, so you guys would be provided with graph paper on something like this, because remember, this is the section that we needed to be really, really, really accurate, so that you knew exactly where the vertices were. So I'm going to draw a coordinate system in here. Okay, so let's start with the first couple. The first couple are very easy. Y is greater than or equal to 0. So this is the line y equals 0, and then greater than means all of the positive y values. So far we've got all the positive y values, which means we could be in the top half. And then if x has to be greater than or equal to 0, this is the line x equals 0. All the positive x values are over here. So far we've restricted ourselves down to the first quadrant. That's where x values are positive and y values are positive. Now we're going to focus on graphing this line right here. So it's in slope-intercept form. We can graph the y-intercept. It's at 4. So 1, 2, 3, 4. And then we've got a slope of -2. So we're going to go down 2 to the right one, down 2 to the right one. Kind of keep this pattern for a while. And then you can go up 2 into the left one, up 2 into the left one. Last thing is it does have the or equal to, so it is a solid line. And we're going to draw it incredibly accurately. And then finally we can test. So less than or equal to, let's test 0, 0. Is 0 less than or equal to 0 plus 4? Yes, it is. So that means we shade underneath. So the part that ends up shaded is this little triangle right here. Okay, so we need the vertices. So 0, 0 is one of our vertices. So if we look at our options, they've all got 0, 0. Then right here we've got the point 2, 0. So that's got a 2, 0. Oh, so it looks like we figured it out already. And then this point right here is the point 0, 4. So that matches with letter B. Okay, number 7, minimum value of this for the feasible region. Okay, so now we've got our vertices. We've got 0, 0, 2, 0, and 0, 4. And then remember the way the min and max thing works is you plug those vertices into your function. So the function they give us looks like this. And we're going to plug those 3 vertices in and then see what we get. Okay, so if we plug in 0, 0, we've got 3 times 0 plus 0, which of course gives us 0. We could plug in the point 2, 0. So 3 times 2 plus 0, that gives us 6. And then we can do f of 0, 4. So 3 times 0 plus 4, that's 0 plus 4. So here is our minimum value. Here is our maximum value. They asked for the minimum value. The minimum value is 0. So that is letter J. Okay, number 8. Let's see what we got here. Oh, the maximum value. Okay, perfect. So the maximum value that we identified right here is 6. So number 8 is letter C. So those are all kind of connected there. Number 9. Okay, so number 9 is one of these fun ones. We've got these triple values here. So for number 9, I'm going to copy this whole thing down. one of those triple inequalities. So I'm going to walk you guys through kind of some tips of how we would do this. So remember, first thing is that you're going to do two combinations, and both of those combinations need to eliminate the same variable. So one of the things that I've had you guys do is get in the habit of labeling equation A, B, and C, and then we know which ones we're talking about. So I'm going to say let's go with y's. Y's look pretty easy to eliminate, especially because this is an instant elimination. We don't have to do any multiplying. So A plus B, let's line them up right here. We've got equation A, equation B. I'm just going to double check before I move on that I've got everything copied down perfectly, because if you're missing even one sign, let's see, it would be disastrous. Good, okay. So these will eliminate. We get a 4x, a negative 2z equals negative 2. So once we get this new equation, we label this D, and we're going to use this in the next step. All right, so next we need to eliminate y again. So now we have to use equation C for sure. So we know we're going to be using C, and then a negative 2y can only cancel with a positive 2y. So we can make this a positive 2y by doubling equation A. So here's equation C. We'll line up double of equation A underneath. So 4x plus 2y plus 2z equals 2. Okay, so that will cancel. I get a 5x, a negative 2z equals 0. So again, I've got another equation in two variables. I'm going to call that E. Now I'm ready for D and E in my next step. So look at Z. Z is much, much easier to eliminate. This is a negative 2z. This is a negative 2z. These are a lot less easy to eliminate in this step. So if I could just make one of these positive, then I'll be good to go. So let's leave E the way it is and then combine it with a negative version of D. So E, just the way it is, negative version of D. So a negative 4x, a positive 2z equals positive 2. So the z's will eliminate. Here I get x equals 2. So that's my first answer. Then remember what you do is you take x and you plug it back into one of either D or E. Let's go E, why not? So 5 times 2 minus 2z equals 0. So 10 minus 2z equals 0. I'm going to subtract the 10 from both sides and divide by negative 2. So z equals 5. That's my second answer out of the three. And then finally I plug these back into one of the original equations and I can solve for y. So let's go into the first one. So A, 2 times 2 is 4, plus y, which we don't know yet, plus 5 equals 1. So 9 plus y equals 1. If I just subtract that 9 from both sides, I will get y equals negative 8. So now I've got all three. Normally, like on your final, you would list the x, then the y, then the z. But of course, since this is multiple choice, they're asking for a specific value. They're asking, what's the value of y? The value of y we just found was negative 8. So for our sake here, we're just leaving letter G. Okay, nice little story problem here. 300 students at home school work a total of 5,000 hours each month. Each student in group A works 10 hours, and B works 5 hours, C works 20 hours, twice as many students in group B. Which equation would not be included in the system? Okay, so let's start with this. Each student in group A works 10 hours, and there's 300 students. So the students in A plus the students in B plus the students in C would be 300 total students. So that's equation C. So that's part of it. Next, we've got 10 hours, so 10 times A, 15 times B, 20 times C would be a total of 5,000 hours. So that is B, equation B. So C and B are included, which means they're not our answer here. Last, there are twice as many students in group B as in group A. Okay, so this is the part that gets a little tricky because A and D are very, very similar. I'm going to play around with some numbers here. So twice as many students in group B as in group A. So let's compare these two equations. So are we saying that group A is double group B, like this says, or are we saying that group B is double group A, like this says? And what it's saying is that group B is double group A. So D is part of our system, which means A is the one that's not included. All right, so for number 10, the answer is A. All right, let's flip to our next page. We're cutting out a bunch of these because we cut out a section in chapter 3. Not a bunch, but a few. All right, number 11. The first row of 4s. Okay, so 4s, we're just going to do the whole thing. So 4s, this is called scalar multiplication. You're taking equation S, or I'm sorry, matrix S, and you're multiplying every single thing by 4. Every single one of those terms. Okay, so everything gets multiplied by 4. So 4 times 6, 4 times negative 4, 4 times 9, and then we do the same thing in the bottom row. So 12, negative 4, negative 20. So again, I multiplied every single thing by 4. So then it's asking for the first row. So you can see right here, letter H matches the first row that we came up with. Number 12, the first row of 2p plus 2r. Okay, so 2p, let's start there. So we're going to take everything in p and multiply it by 2. So we're just doubling those values. So 8, 2, 4, and 0. And then 2r. So again, everything in r, and we're going to double it. So 2 times 0 is still 0. 2 times 1/2 is 1. 2 times 1, of course, is 2, and then negative 4 here. So now we're going to add them together. So 2p plus 2r. The way that we add these matrices together is we add all of their corresponding elements, which means if they're not the same size, we couldn't possibly add them together. So 8 plus 0 is 8. 2 plus 1 gives me 3, 4 plus 2 is 6, and 0 plus negative 4 is negative 4. So that's what we get when we add them together. Because they're the same size, we're good to go as far as adding them together. So 8 and 3 is the first row, so that is letter A. Okay, S times P. Let's look at that one. So S and then times P. Okay, so let's label the dimensions. The dimensions are the rows by the columns. So here I have 2 rows times 3 columns, 2, 3. Here I have 2 rows, and it's a square, so I have 2 columns. If I'm allowed to multiply matrices together, their middle numbers have to match. Here the middle numbers do not match, and so I'm not allowed to multiply them together. If we were allowed to multiply them together, remember the way this works is you circle the row here, the column here, and then you match each term and multiply it together. But the reason this one doesn't work is because we do 6 times 4, then we do negative 4 times 2, and then the 9 doesn't have a buddy. That's why this would have to have the same many, or as many rows as this one had columns. So this one does not work, so we'd go with letter J, not possible. Okay, skipping down to 15. Okay, the determinant of Q. So let me get Q on the screen here. So we've got just this very quick formula here. We multiply the downward diagonal and we get 2, and then we subtract the upward diagonal. So 0 times 6 is 0. So again, downward multiply minus upward multiply. So this just gives us 2. That was a very quick and easy one. So that's letter H. Number 16, okay, another determinant right in a row. So same process, pretty quick and easy process if there are only 2. So 5 times 2 is 10 minus 3 times 1, which is 3. So that gives us 7. And that is letter B for number 16. Okay, number 17. So this one's a little weird. Which expression is true? So I'm going to make sure those are up on the screen. So which expression is true? This C and then x plus y is the same as y plus x times c. That actually might work, because if we're adding here, it doesn't matter what order we add them in. Addition is commutative. And then if you multiply times c on the left versus c on the right, so this one might work. This one, x times y is the same as y times x. That is absolutely not true. You have to multiply matrices in a certain order. So h is out. This one, okay, so this one messes us up again. X times y is not the same as y times x. You can't multiply in any order that you want. Here, c times xy, it's not the same as c times x and then c times y, because you'd be multiplying the c twice. There'd actually be a c squared there. So when you're doing x times y, you don't distribute the c to both of these things. So j is out as well. So we're going to go with letter F. You can add matrices in any order that you want, but you cannot subtract, or I'm sorry, you cannot multiply them in any order you want. Okay, 18 is one of those three-dimensional determinants. And 1, -2, 5. Okay, so the first thing you do with these ones, remember, is you take the first two columns and you copy them off to the side. Okay, and then we do the downward diagonals first. So 2 times 1 times 5 gives us 10. 0 times 2 times 1, always 0. Anytime I come across a 0. 1 times 3 times -2 gives us -6. And then we go up these diagonals. 1 times 1 times 1, of course, is 1. -2 times 2 times 2 is -8. 5 times 3 times 0 means we get 0. So we take the numbers on the bottom and we add them all together. And then we take the numbers along the top and we subtract them. So -1 minus -8 minus 0. Okay, so the zeros aren't doing anything for us. This becomes plus a positive. So I have 8 and 10, that gives me 18, and then -6 and -1, that's a -7. So that subtracts and gives me 11. So that would be option C. Okay, it looks like we're doing 19 and skipping 20. Okay, so number 19, Kramer's rule. Okay, so we're solving 2m plus 3n equals 11, and then 3m minus 5n equals 6. So I know it's just asking you for one specific thing, but I want to walk you through how to do the whole thing. So we have these three matrices. We've got a matrix that we call C. Those are the coefficient matrix. And so for this, we literally just take the 2, the 3, and the -5. We pull the coefficients right off of these three right here. We have another matrix that we call CX, where we replace the x column with the constants. So instead of the x column, we have 11 and 6, but the other column stays exactly the same. And then we have this third one called CY, where we replace the y column with the constants. So the 2 and the 3 stay, and then we replace this with the constants. Okay, so those are our three matrices. Then, to get our actual values, I guess I should say, I'm sorry, this should be an m instead of an x, this should be an n. So to get m, we take the value of cm and we divide it by c, and then to get n, we take the value of cn and we divide it by c. So the multiple choice is kind of a strangely worded question, but it says which determinant represents the numerator for m. So that would be this right here, which would be this right here. So that would be letter J. Okay, we're skipping over 20 because we didn't do inverse matrices. And then we're going to do the bonus really quickly. So this is a determinant sort of thing. So 0, 1, 0. So this is just going to have a bunch of letters all over the place. So it's going to make this one a little bit weird. So box this in. So same thing we did up above with 18. We get these, the first two columns. So go down the diagonal here. 0 times b gives me 0. Don't make it a b squared. Be careful there. 1 times c is a c squared. 0 times a would be 0, because you have that 0 there. C times b times 0 is 0. A times c times 0 is 0. And then b times a times 1 is ab. A times b. So we take this thing along the bottom here, add them all together. So 0 plus c squared plus 0, and then we take the ones along the top and we subtract them. So -0, -0, minus ab. So the only ones that count for anything are the c squared minus ab. So that would be the answer for the bonus. Definitely a little bit tricky. All right, so that's it for chapter 3.